All right, I want to look at this powers of cosine and sine problem. Um, Jennifer asked the question here and got a good start on it. Let's just finish it for you. Cosine squared x is 1 plus the cosine of 2x over 2. That's the power reducing formula, or the half angle formula. I think of it as power reducing. You did notice that the sine to the fourth, you're going to think of this as, cosine squared x, and then the sine to the fourth is actually sine to the squared x squared. So the sine squared of x in there is 1 minus the cosine of 2x over 2, and you got that squared. Okay. So what we have is we've got a few things multiplied out here. Hang on a minute. Okay, I just got interrupted, but here we go. This thing right here, uh, I want to write it as 1 plus cosine 2x over 2. And then this, I've got the same thing twice. I've got a 1 minus cosine 2x over 2 and another 1 minus cosine 2x over 2. The reason I do this is because I'm thinking about, I've got three things multiplied together. One of these things and two of those. And I either have to multiply these two together and then that one, or multiply these two together and that one. But it's going to turn out to be easier to multiply it this way. Hang on again. I'm sitting here in my office recording this, and it's getting really loud in the hallway outside, and so I had to close my door. So here we go. I'm going to multiply these two things together. Actually, I'm just going to take there's a half times a half times a half. That all comes out as an eighth. Okay, and then when I multiply the 1 plus cosine 2x and the 1 minus cosine 2x, I'm foiling. So I got a 1, I got a minus cosine 2x for the outsides, plus cosine 2x for the insides. Those cancel out. And then you get a minus cosine squared 2x. Right? And I still haven't multiplied in that other 1 minus cosine 2x out here on the end. Right? But what happened now is I've got a 1 minus cosine squared 2x. I got a cosine squared. Again, I've got a situation where I can use a power reducing formula. So this thing right here, I've still got the 1/8 out in front. Now I've got a 1 minus, and this is a 1 plus the cosine of 4x all over 2. That angle doubles each time you use the power reducing formula. And then I've got a 1 minus cosine 2x here. So, I'm going to factor out another 1/2 to get a 1/16 here. When I factor a half out of 1, it leaves me with a 2 minus, and then this stuff, 1 minus, plus the cosine of 4x, and then all this. Okay, I'm minusing this whole thing, so I was careful to put that in parentheses because there's going to be a distributive property there. Okay, the 2 minus 1 is going to be a 1, and then I have a minus the cosine of 4x, and I still have this 1 minus cosine 2x that I haven't done anything with yet. Okay, so I distributed the minus sign in here and there, and then the 2 and the minus 1 combined to be that 1. So now I can multiply this through, FOIL that out. So I've got 1/16 times 1, the outside is minus the cosine of 2x, the inside is minus the cosine of 4x, and then lastly I've got plus the cosine of 2x times the cosine of 4x, and I think it's now starting to look like what they wanted for a solution. Yes, they had this A, B, C, yeah. So when you multiply this all in again, it looks like this is a 1/16 and then a minus 1/16 cosine 2x and a minus 1/16 cosine 4x and a plus 1/16 times the cosine 2x cosine 4x. And so those were the things they're looking for, were those coefficients, right? But what we had was we had a power reducing formula on the cosine and on the sine, and then we multiplied that out and found another cosine squared, which we used another power reducing formula on, and then just multiplied everything out again and see what we got. Okay.